Alright, so right now we're going to discuss about the reactions of carboxylic acid derivatives. Now the derivatives of carboxylic acid includes acid halide or acyl halide, which looks like this. Now this, with the elimination of the halide, looks like this. So this over here is called an acyl group. And then we may see reaction of acid anhydride, which looks like this. Then we may see the reaction of esters, which looks like this. And then we may see the reaction of nitriles, which looks like this. And we may see the reaction of amides, which looks like this. Alright, so the reactivity of these goes in the order. The most reactive is acid halide. So after that we have acid anhydride. And then many books differ in this, but we may see that in our book the esters and carboxylic acids are having equal reactivity, and then we have amides. Alright, so moving on, we may see the reactions. So first is the reaction of acid halides. Since they are the most reactive, they show variety of reactions with alcohol, with amine, with carboxylic acid, and with water. So I'll just write the general scheme first. With acid anhydride, we may see with alcohol, with amine, and with water, but not with carboxylic acid. And then we may see the reaction of esters with Grignard reagents, and then we may see hydrolysis, and we may also see reduction. And then we may see nitriles, which follow the same rule with like esters with Grignard reagents, hydrolysis, and reduction. And then we may see the reaction of amides with actually that's only hydrolysis and reduction. Slight correction is that it doesn't react with amine, but with ammonia. So I also wrote out the reactants and the conditions involved. So for acid halides, with alcohol it's going to react with concentrated H2SO4, and then with carboxylic acid it's going to react in the presence of pyridine, and then with water it's going to give a violent reaction. For acid halides with water it's going to react in acidic or basic conditions. So basic conditions has sodium hydroxide, and acidic conditions will have either a proton or concentrated H2SO4. And then with esters it's going to give hydrolysis in basic conditions for subonification, and acidic conditions are protons. And for reduction, for all the reduction we are going to use lithium aluminum hydride in dry ether. Alright, so moving on, we may see the reaction of acid halides. So we may react it with water, so with alcohol first. So we have an alcohol over here. So what it's going to do is the Cl- is going to remove, and then we may form the H is going to remove, and then we may form a ester. And then with ammonia it's going to react it like this. The H and the Cl is going to remove, and then we may form an amide. And then with carboxylic acid we may form an acid anhydride. And then with water we may form a carboxylic acid. Now we have the reaction of acid anhydrides. So with alcohol it's gonna break up like this. So what's gonna form with this is an ester and a carboxylic acid. So with ammonia it's going to react like so. What's going to do is it's going to form a carboxylic acid again and a acetamide and a amide, alkyl amide. So the reaction of, if we see the reaction of water, we'll see that it forms two carboxylic acids this is going to combine with that, and then this is going to combine with that. So when we react esters with Grignard reagents, this is going to attack over here, this is going to attack over here, it's going to form a magnesium carboxylate complex, and then what it's going to do is going to form a ketone, and then this ketone is going to react with another Grignard reagent, and then it's going to form a 3-PB alcohol. And then if you see the hydrolysis reactions, first we're going to see the basic hydrolysis. So what we have over here is a sodium hydroxide. So this process is also called as saponification, because what we create from it is soap, which is sodium acetate and water, and we form alcohol actually. And then with acidic hydrolysis, we form a carboxylic acid and an alcohol. So moving on, we may see the reduction. The reduction of esters would give with lithium aluminum hydride in the presence of diether, it would give us alcohol, 1-degree alcohol. Alright, so if you see the reduction of nitrile, and if we also see the reduction of amides, so we may see the reactions of both of these together because they are somewhat similar, and they may get confusing if choices of MCQs are given. So I'm going to discuss them all together. What's going to happen is the reduction part is going to be the same. The reduction of nitrile and amide is going to give us a 1-degree amine. We're going to follow nitrile. We're going to react with water. It's going to form an amide. And an amide is going to react with water and also form a carb acid. So if the question comes that the hydrolysis of nitrile will give an amide, following hydrolysis will give carboxylic acid, and then we may see the reaction of nitrile with Grignard reagent. React with Grignard reagent, it will form a ketone. How it will form a ketone, I'll show you. So this part attacks over here, this part attacks over here. Then water vapor will occur, and this oxygen is going to combine over there, and then it's going to form a ketone, and then we will have ammonia and ketone formed. And then for the hydrolysis reactions, you may see that heat is also involved and acidic and basic conditions are met. For example, sodium hydroxide or concentrated H2SO4 is used. So what we see is when we heat it up, we form an amide, and then that amide acid water to form carboxylic acid. So the reduction uses lithium aluminum hydride in dry ether. So what's going to happen